My name is Catherine St. Gabriel. My topic for this week is on plane trusses and method of joints. This is for the class BNC 2405. I want to start off by talking a little bit about what a truss is. So basically, trusses are just a structural system, and they're made up of straight members that are connected in a triangular pattern, and they form a web-like formation. And typically, trusses are made out of steel or timber, and they're used for various applications. And if you look at the picture right here, you can obviously see the triangular pattern that goes across the bridge. And some examples of seeing this triangular or like the truss in a structural system is buildings and towers as well. Two force members. So trusses can be made up of two force members, which mean they can either be tension or compression. And if you look at the picture, the first picture, tension, you can see that the forces are going to be moving away, while compression means that they're going to be moving towards it. As for the second picture, you can see that all the beams are connected at their endpoints, which is here and here. And that just means that the forces are going to be acting at each end. They have an equal and opposite. And if you draw an X and Y plane, you can see that they're going to be acting on the line of action as well. Zero force members, as the name implies, that just means that there's zero forces acting upon them, and that means it just equals zero. And there's two methods of finding which members are zero. And one method is when you're looking at two members at the joint, which the joints are going to be these circular points right here. As long as you look at the members and they're not parallel and there's no load, external load acting on these joints, that means that they're going to be zero. So an example would be probably G to L. And the second one would be members that are parallel, but they don't have any loads acting on them at the joints, then the members are zero as well. So that would be D and J. And so trusses can be broken down into two other categories, which is plane trusses and space trusses. Plane trusses, they're basically when the members are going to be on a single plane, and you can kind of treat them as 2D systems. And if you look in this example here, you can see that they also have the triangular structure here, and this is what a plane truss would look like. Space trusses, on the other hand, they're kind of the opposite of what a plane truss is. So they don't lie within a single plane, and they need to be analyzed as a 3D system. As you can see in this example, you can see that this is more of a 3D look. We're not going to be working with this system, but I thought it would be nice to add this example. And to solve for the unknown forces that are acting on the trusses, we can use the method of joints. It's known to be faster and easier to solve for and find these unknown quantities. And the way that this method works is that you focus on the center of the joints or the connection points. So here, between each member. And there's going to be at least one or two unknown forces that we have to solve for. And the way to solve for them is that with using the method of joints, we have to imagine that there are pins at each end of the points. And we start off by drawing the free body diagram. And this just gives us a clear picture on what we need to find and how many forces are actually unknown. And next up, we have to write out the equilibrium equations. And then finally, we solve for each one, and this can result in a larger number. And this method lets us find larger quantities for unknown forces. And I just provide an example of what I'm trying to say. So you can see there's already Fx, and you can figure out how they're solving this one by drawing the free body diagram here, and sine and cosine. Just wanted to show a few other examples about how we use the method of joints. As you can see in example 6, you can see the 3 equilibrium equations that they use, making sure that they all equal 0, and the forces that are acting on each joints either going up from the side or down, depending on the force. And if you look at the second photo over here, you can see where they highlight certain parts where there could be tension or compression, depending. And they use the vectors, or it could be scalars, to show where these forces could be going. And I also wanted to mention one more thing is that if you get a negative number, that means that there are compressive forces acting on it and it's not tension. So that's kind of how you can tell the difference between which is going to be tension and which is going to be compression when you solve for these equations. And for my presentation, thank you, and I hope everyone has a good day.